We're here at the Embedded Group with Scott Davis, and you just want to talk to us a little bit about embedded devices and where things are going in the future.
Absolutely. What we're looking at, we have a launch coming up for a new release of Windows Embedded 6.0. That's in Tokyo next week. What has come about with this launch is that we've, as a group, been taking a hard look at what's going on in the embedded market space itself, where that's going. And that's why I called you and wanted to talk to you about some of the ideas. I think they're very interesting and would be particularly interesting to your audience.
So how far out do we look at Microsoft?
We're going to be looking at about 7 to 8 years.
Cool.
As what's going on. And this is the trends in the industry in general. It's not just where we're going, although we're positioning our products to be in line with where devices are going in the future.
How do they determine where things are going to go, or
what
trends are?
It's actually pretty straightforward. If you look at the history of what's been happening in computing in general, and then put that on top of what the history has been with embedded devices, there are clear trends that you can see. And it doesn't take too much to start folding over and going, okay, what would be the next step? What would be the next step?
Cool. And what do we have here today? What are we going to look at?
Well, the first thing is, when I talk about embedded devices, I know that's not a term that's used in the consumer industry that much. An embedded device is any device that has an embedded computing system that is dedicated to a single function.
And embedded meaning it's on a chip?
Exactly. It's inside. It has its own operating system. It's running some instruction set. So at home you have, I think you have the world's fastest computer.
Right? It might be close.
Right,
yeah.
right. Your internet machine is what you called it.
Yes,
right.
My internet machine.
And that's a general computing device, right? It's meant to do a lot of different things. If you look at a phone, for example, this is mine. It's meant to be a phone, but it has a camera in it. It has so I can do email.
Web browser,
yeah, exactly.
Email, everything.
But those items are dedicated. This is what this phone is meant to do. And inside there is a processor. There's RAM. There's storage. Very similar to your computer at home. And it's also mobile and much smaller. Everyone has their world filled with embedded devices. We're talking about your, if you have a set-top box, for example. We have Comcast here, so I have a Comcast box with a DVR.
Yeah.
That's an embedded device. You likely have a thermostat at home. Now, if you pop off the cover and you don't see a little vial filled with mercury that pops back and forth to turn it on and off, but it's digital, that's an embedded device. Your ATM is an embedded device. Your alarm clock, your phone, your MP3 player, these are all embedded devices. So the first wave of embedded devices were really going from the straight mechanical to a computing device, some sort of intelligence going on. And I mentioned the thermostat. That's probably a good example that most people grew up with is if you did pop off the top, you would have seen a glass vial full of mercury, and it moved back and forth. It was purely mechanical. As we move from that to moving to a solid-state, circuit-based, computing-based device world, the first processors that came in were very slow. They were 4-bit, 8-bit processors. The instruction sets were very limited. The amount of input, the user interface you could expect was very limited. Now, once that moved over into the next phase, we moved to what we call smart devices. And that's, if you look at your VCR, that's a good example. It moved from being a tape-based machine where you put it in and had to set the channel. Yeah, exactly.
Yeah.
And then they tried to improve the user interface over time. They tried to make it smarter to anticipate how humans work with the device. Now, these devices would both be considered smart. These are remote straight from my house. This is what comes with my TV, the cable box. I think most people are aware of something similar to this. Now, if I wanted to input instructions into this, I can. It's programmable so that I can control my TV and my VCR, my cable, all in one.
Yeah.
it's not exactly intuitive.
It's not.
Yeah, if I sit this down and say, figure it out, you would have a little trouble. This would still be considered a beginning edge smart device. Now, if you move through time, you see the natural evolution of something like this. Now, this isn't that expensive. It's the, who makes this? The Logitech, yeah. And you can see now the user interface has become much more intuitive. It says watch TV, watch your DVR, go look the computers. I have my computer hooked up to the TV.
Yeah.
Watch a computer. It does a lot more. The processing power is greater here. So that's just the beginning of the trend that you're starting to see in smart devices. The processing power is getting larger. Now the next thing that we moved into, and that's the wave that we're in now, is these devices became connected. That first it was a tethered connection, so they could start exchanging information, and then they got IP addresses. And that's where we are now. And if you look at something like a Zune is a good example of that. The MP3 players that came before it were connected in terms of you hooked up via USB to your computer. You could download information. It was smart. It had heavier processing power than those that came before it. It had an intuitive interface. But the connected allowed you to get away from being tied to just a specific experience contained within the device.
Yeah.
Now, if you move that one step further to what you're starting to see right now, the edge of what you're seeing when in the smart connected devices right now, the devices themselves are moving away from being the focal point of what you're looking at. I'll give you an example. MP3 players, when they first came out, and there were more MP3 players before Apple and Microsoft got into the market than there are now. What was the major features that you were competing on? Storage was the biggest one.
Yeah.
The number of things that the device could do. Could it have a voice recorder in it? Did it have radio in it? I mean, it just went on and on. The number of things that they were jamming into there, and they weren't very friendly. They weren't centered on the music experience itself.
Yeah.
And then you take where we are today. The two major players in the market, and I'll use Zune because we're Microsoft, and that's easy for me. They've moved from the idea of the device being the entire focal point of what you're doing to the experience of what you're doing being into the focal point. All right, the user experience. So I listen to music. All right, how do I do that? I have music on my computer. I want to share that music with people. I want to sync that music with my other computers that I have and with my portable device that I have. I want to find music. I want to buy it. And when I buy it, I want it to spread out through the devices that I have. I don't want to think
you want to
about...
be able to listen all over your house,
right,
in your car.
Right. I want to listen to music. I don't want a device that I have to go figure out, okay, how do I listen to music here, and then go to another device and go, okay, how do I listen to music here? The focus has moved away from the device to my experience as a music listener. And you can see other examples of that beginning to happen. And that is when I talk about the evolution of devices, this is the next wave that's coming. And this is being made possible by, again, higher processing power. So again, they're moving up and in the speed with which they can process, and they're getting smaller. So the battery life to the power ratio is changing.
And wireless plays a part in that?
That's the other thing. So if you look at the smart and the connected, you'll see that now the boundaries are being broken of what you can do and where you can be when you're doing that.
So now we're starting to get a better picture of why wireless was put in the first Zune, and for it wasn't just sharing things with people. And
right, exactly, and that's actually the point of when we talk about the on-10 audience. I've been involved for 2 years now. I know that the audience is intelligent as far as understanding what's going on in the marketplace. What's interesting to me about this is, in this group now, I'm getting a broader vision of what's going on in the trends of why the market is moving in the direction it's going to, and the evolution of devices that are likely to happen. You taking pictures, for example, cameras. Right now, you're still competing in cameras largely on features. What's the next 10 megabyte pixel monstrosity that I need to have?
Yeah.
How many chips does it have into it? How many, what's the greatest features that it has? But anyone who's into cameras knows that a lot of that stuff is being wasted now. The power of the most powerful cameras are largely well beyond what the average user needs. Mm-hmm. Take that to the example of in the music. You take pictures. What do you want to do with pictures? You usually want to take pictures, you want to sort them, you want to share them, mm-hmm. you want to sync them. It's very similar to music. Now, if you start bringing in digital picture frames into the picture, and the idea of looking at your pictures and your movies on your TV set, of sharing them across the cloud with the friends that you have, of tagging them while you take them so that they automatically get sorted in different places. That, I would say, is where we're going to see this industry move. Mm-hmm. And looking for devices that are starting to show those features, starting to show the intention of moving in that direction, is something that I think would be very interesting to watch. And I have no doubt that that's what's going to happen. Mm-hmm. The next wave, if you look at, we talked at the beginning of how far we go, you look at now what we can do 9 years from now. Processing power increases, they get smaller, battery life extends, they're now connected. The next phase is, what if they can start accepting services? And this is something that we talk about at Microsoft a lot, the services, software as a service. And usually software as a service means bringing in information, bringing in a service into an existing application. Now, what if do you have a GPS device?
I do.
All right, a portable one? Okay. Does it have traffic monitoring?
It doesn't, but okay. It's a CE device, so I'm hoping the latter someday.
That's good. Now, if you look at how that device right now would accept traffic information, real-time traffic information, what they do is they bring in the information from some sort of feed external to the device. Mm-hmm. Usually it's a government-provided feed of the local government has put it cameras or sensors somewhere on the major thoroughways to know what's going on in the environment and sending that to you. That's how you get it. If you're on a side street, there's no traffic information there. There's no way to have it. Mm-hmm. Now, if you look at a device that's as powerful as they would be 7 years from now, as far as the instruction sets that it can handle, it's already IP connected. The idea of connecting to the cloud is very established. This device, a GPS device, knows where it is, and it knows how fast it's going. What if it pushed that information back up, brought all the information from all the other GPS devices on the roads together, created its own service, and then pushed that back down? Now you have real-time traffic information everywhere because you have GPS devices everywhere.
I like that.
Yeah, you could roll this same scenario across many different industries. For example, if you have any device with a display, it knows what it's using on its display. It knows when someone's using the real estate of its display and when they're not. Mm-hmm. You have displays at gas stations. You have displays at ATMs. You have displays on your phones. There's displays here. What if, to offset the cost of the device, they are pushing the information up that says, my display is now free. I'm willing to accept some form of advertising or some form of user content that is being brought down that I've subscribed to, that I want to see flickering across. So now you have an entirely different model for how you offset the cost of these devices. I can bring in advertising and push them across displays because the displays themselves are talking to each other and saying, we're here, we're ready to accept a service. So the service of the device, and I know this gets a little tricky, the service of the device is actually the information of the device being pushed back up. I'm here, I'm aware, this is what I can accept. Or this is how much downtime I've had. I'm broken, I am out of money, I'm an ATM machine, I'm empty. All these information coming back up so that the management of these devices that are going to proliferate is possible. So that's what we're looking at. Smart, connected, service-oriented. The idea of not only the dangers of what happens with this, but the security concerns. I think that's going to be at the forefront as well as one of the problems that we're going to have to solve. Just as when we became connected in our computers, What was one of the first things that happened? Viruses, right? We're all connected now. Oh, crap, we got to deal with that.
Yeah.
I think that if you look at the history of what's happened with viruses, malware, adware on the computers, you can see that it's relatively under control now. It's something that we are aware of. We know that we have to fight it, and we've put constraints in place.
I wouldn't mind having a pushed scenario where people say there's a speed trap here.
That would be interesting.
But I just don't want to get an automatic speeding.
That's a great idea, and actually something I never thought of. You're talking about the idea. I've been thinking the whole terms of corporate pushing out services. But if you take something like the Wikipedia model of saying, okay, users have these devices, they have information as well, so that you're not just blinking your lights.
Yeah.
And how far do you have to keep blinking your lights anyway? That's the one thing I've always had difficulty with. Like 3 blocks I get, but further down the road, do they even know?
Yeah.
That's a non sequitur.
$1 million idea.
Exactly.
Free.
But the idea of user-created services would be very compelling, because I don't see any reason why you couldn't do that.
Yeah.
They're going to have the interface. They're going to be much more powerful. They're going to be programmable to some extent. Mm-hmm. It's not hard to see a feature button that says, speed trap. Yeah. Or, Walmart 2 miles ahead.
All right, so I guess this will be the first unboxing of this product. I've never seen anything like this before. This is by Neonode?
Neonode. And this is a...
What exactly is this?
What is a Neonode? This is very interesting. This came to us. It's I know they're being sold in Russia. I do not think they're available here in the States. This is a phone, and we'll get some close-ups in a second, that is based on Windows Embedded CE 6.0.
And we don't know if this will work in the U.S., but I did stick my SIM card in there, and we had 4 bars. And
we did get your SIM card in there, but we couldn't figure out if we were making calls or not.
It said dialing, but whatever.
Right. What I wanted to show this for was... again, if you look at the evolution of what's going on, from going to features of how much stuff can I pack into it. If you see the beginnings of user-centric experiences of what's going on, again with music, with camera, you'll see the same thing happening with phones.
As the biggest changes seem to be with interface.
That's the point, right? So if I'm moving away from trying to jam as much stuff as possible into a device to saying, okay, what does the user want?
Yeah.
What's become more important to the user? Now that cameras on every phone, now that they all have some form of instant messaging on them, some form of connection going on, they can store some amount of music and pictures. What do you start looking at next that you compete on? Well, you go to the individual, all right? And so this phone, and we'll have to show it, you can see it doesn't have a keyboard. It's actually touch sensitive, and this you won't be able to feel because you're not here with us, but every time you touch one of the numbers, it vibrates.
Tactile feedback.
It's letting you know what's going on. And all the functions as far as...
It's a pretty stiff little thump when you click on a key. You really know
you've done something, exactly. And this is the beginning of saying, what does the user want in a phone? I've got all the features I want. Now let's go to the user and say, this is the type of experience that I believe users would want. And there's no right or wrong answer. I want a keyboard. Yeah. I know I want a keyboard because I do a lot of email.
Yeah.
This is 80% email machine for me. Mm-hmm. That's what I use it for. If I was going out at night, which I don't do anymore because I'm married with children, but I've heard it's fun, yeah. I would want something smaller. I don't want something this big to go around with it. So you see the divergence of the different experiences that individual users, in marketing terms you call them segments, are interested in. And the device is catering to these different segments. And that's again, the most exciting thing about that. These devices are wrapping around us, not the other way around. There is some confusion in the market as far as what's the difference between Windows Embedded CE, Windows XP Embedded, and Windows Mobile. Not to get too complicated, but the essential core operating system, the kernel, so to speak, of these of CE and mobile is the same. Now, mobile has since taken that core base and moved on to create a software package that is very specific to phones, and that's what Windows Mobile is. Now, CE is meant for the embedded world of devices. It's highly configurable as far as the size of the operating system itself. When you sit down with Windows embedded CE, you sit down and say, okay, what features do I want of the operating system? You can take all of them or just very few of them. So the footprint of the operating system can grow or shrink incredibly. And that's important for if you have something like this compared to something like, well, that wouldn't be CE, something like this, the size of the processing power that you need is very different.
Yeah.
So if this is Windows CE, which is fine, and you can see that the interface that Windows Mobile will keep you in, under CE, this manufacturer doesn't need to constrain themselves to that.
And
It's exciting. It's very exciting.
so what's next up on the horizon?
For the devices themselves is definitely start looking for the devices that are already advanced in the connected space. They're smart and they're connected already. Watch to see what's going on with them as the push becomes to saying, okay, how do we get user-centric? How do we understand how this device works into someone's life? Watch for that. The next thing, watch to see these devices as they become more powerful. They start becoming service aware. They're bringing in information, which is already starting to happen now, and in the next stage, they'll start pushing it up. And if you look at what happens when you start pushing up information, it opens up a whole world of possibilities. I mean, it is just incredible what you can do if the devices themselves are saying, this is where I am, this is the information I have, I'm making that available, let's aggregate it together, let's see what type of possibilities this information has. The Imagine Cup 2008 is opening. Go to the Imagine Cup website. You can get in, if you are a student, which I know some of your audience is, that is a great way to get involved in designing embedded devices, getting hands-on into it, understanding what this is all about.
All right. Well, thanks for meeting with us today.
Thanks, Larry. I appreciate it.
Thanks.